Hi everyone, let's explore some code today. We will speak about LeetCode coding challenge number 54, spiral matrix. We are going to solve it by using Java and ArrayList. First of all, let's see what's in the description. Given an m multiplied by n matrix, return all elements of the matrix in spiral order. In example, we can see the spiral order itself. It goes from left to right and then from top to bottom, then right to left, and it ends in the center. There is also example of input and output down below. In the input we have a two-dimensional array with 3 sub-arrays inside. And the output is a new array that holds the spiral order from example below. It's 1, 2, 3, 6, 9, 8, 7, 4, 5. Our job is to create an algorithm that takes an input array and converts it to the new array according to the spiral logic. I could possibly solve this challenge with a double for loop, just adding values from sub-arrays one after each other, but it will be difficult to come up with a spiral logic. Besides that, it's a two-dimensional array and it will be a huge impact on time and space complexities. The best approach here will be to use some data structure which allows to add values according to the examples and handle spiral pattern along the way. Depending on the chosen data structure, it will be a couple of nuances to follow in the process. The main concern here is that we should be able to handle the edge cases, means gather the values from subarrays to the new array. Also, we want to be able to add values to the new array in a spiral manner. We can just get flattened array by concatenating subarrays to each other because the output will be incorrect. Also, we want to avoid duplicates when it comes to shifting between rows and columns. We will handle it later. I will show how. We can use an array list for those purposes. In terms of complexity, the best case scenario will be bigger O of nm, where n is the number of rows, m is the number of columns. That goes both ways. Neither it's a time nor it's a space complexity, because we need to visit every value of the input at least once, and we need to take space based on number of rows and columns of the same matrix in order to return it in a certain way, like it's shown in an example. So it's a bigger O of nm. Let's start by declaring array list with integers. Let's call it result, and then let's declare important values that are going to represent edges of the matrix. It's top, bottom, left, and right. Notice that we have sub-arrays. To pick the last one, which is the bottom one, we will use matrix.length -1. And to look for the last value inside each sub-array, we will use matrix 0.length -1. Now logic will use while loop and boolean true. To avoid infinity while loop, we want to break the flow within the if statement. We will see this statement again down below. In general, if statement here says that we cannot go over the boundaries, like left should never be greater than right and top never should be greater than bottom. We also will have a bunch of the for loops to go over the edges of the matrix. Let's start from the top. We have to go from left to right and add each value to the result array. The way we are add the values to array list is to use matrix with a current row and column, which in our case is a top and I, where top is a row and I will be each column. Values on intersections will be the values that we adding to result. Each iteration we are adding a new value until we met the end of condition of the loop, and then we are going to break. Same thing we are going to do with another edge of the matrix on the right, but this time we will do some changes to match our spiral pattern. This time we will go over the values from top to bottom, adding only values from the end of each sub-array. How do we get the last values from sub-arrays? Very simple. It's matrix 0.length -1, where matrix 0 represents sub-arrays and length -1 represents last value. After adding values to result array from the right edge of the matrix, we will have some duplicates. That happens because top edge and right edge have the same number inside. It's number 3. To avoid duplicates, we want to shift starting point of iterations to the top + right after the loop is over. Same thing with loop below. We're going to add right --, so the loop below can start from another position to avoid duplicates. Now we are just going to apply similar logic to other edges. Let's do bottom edge next. Notice that we are moving backwards and for loop have to do I -, so we can move from right to left at the bottom edge. Don't forget to make a shift and break after that, and the last one edge will be a left. Let's also add return statement with result array in the end. Now we can run the test and see if everything is correct. That's pretty much it. Thanks for watching me. If this video was helpful and you want to see more videos like this, please like and subscribe. It helps channel a lot. And see you in the next one.